Good day, viewers. I remain Adeyeye Adeolu Peter. I am a favorite tutor. So today we want to look at oxidation number. How do we calculate oxidation number? So we have about 6 rules on the board for us to calculate oxidation number. So the first rule says the oxidation number of oxygen is always -2, except in peroxides where it is -1. So, and you must know examples of peroxides. As you can see, we have different examples on the board. Hydrogen peroxides, potassium peroxide, sodium peroxide. So if you calculate the oxidation number of oxygen in this compound, you are going to get -1. But in every other compound, the oxidation number of oxygen is always -2. Number 2 says the oxidation number of hydrogen in most compound is +1, except in a hydride where it is -1. It looks as if that exemption for both oxygen and hydrogen is the same, -1 and -1. Then the examples of hydride. Hydride is any compound where you have hydrogen at the very end. So these are examples of hydride. We have sodium hydride, we have potassium hydride, calcium hydride, magnesium hydride, and we also have many of them. So the oxidation number of hydrogen in any of this compound is going to be -1. So we are going to be doing that later. I will give you examples later. I'm going to show the calculations later. Then number 3 says the oxidation number of any ion is equal to the charge on that ion. And then I showed you some examples on the table we have here. You can see this hydrogen ion. The oxidation number of hydrogen ion is +1. Then this is calcium ion, Ca2 plus. The oxidation number is +2. So the oxidation number is the charge on them. The charge on hydrogen ion is plus. So this plus means ordinary plus 1, which is this. Then we have calcium 2 plus. So the oxidation number just leaves what we have here. That's what? +2. Then we have O2 minus. The charge on oxygen ion here is -2. So this is what? -2. Aluminum 3 plus. So the oxidation number is +3. Then Cl minus. This chloride ion. So the oxidation number is -1. So that's how we get the oxidation number of any single ion. Then number 4 says the oxidation number of any element in the ground state, that is in the uncombined form, in the uncombined state, is 0. For example, if you have, let me say, sodium plus chlorine to give sodium chloride, you can see this equation, you can see this reaction, all right? So in this equation, on the left-hand side of the equation, we can see that sodium is in the ground state, and therefore the oxidation number of sodium here is going to be what? 0. Then on the left-hand side again, chlorine is also in the ground state, in the uncombined form. Chlorine is not combined with anything here. So the oxidation number of chlorine here is going to be what? 0. But coming to the right-hand side, the oxidation number of sodium on the right-hand side can no longer be 0 because it's now combined with chlorine. The same way, the oxidation number of chlorine here can never be 0 because it's now in a combined state. All right. Then number 5 says in a compound, the sum of the oxidation number of individual elements that makes up that compound equals 0. I am going to show examples later. Then the last one says in a radical, e.g. CO3 minus, this triazocarbonate 4 ion, then NH4 plus ammonium ion, then we have MnO4 minus, which is tetraoxo manganese 7 ion. It says the sum of the oxidation state of individual elements that makes up the radical equals the charge on the radical. So these are examples of radical. These three, CO3 minus, NH4 plus, MnO4 minus. Okay, so I am going to be showing some examples right now. I'll be showing some examples, right? So please just follow me, follow me, follow me, follow me. All right, calculate the oxidation number of the underlined elements in the following species. Number 1, we have calcium carbonate, C. Number 2, we have NO3 minus, N. Number 3, we have Cr2O6, sorry, Cr2O7, 2 minus, Cr. The number 4, MnO4 minus. Number 5, NaH. Okay, here we have Mn underline. Here we have H underline. Okay, so let's confirm that some of these rules I just gave to us. All right. So we have some examples on the board. Now, the solution. Number 1, we have calcium trioxocarbonate 4. And we are asked to find the oxidation state of carbon. Now, there is a rule I did not give to us. And the rule has to do with metals. Now, since you are asked to find the oxidation state of carbon, then definitely you must have known the oxidation state of every other element in this compound. And what are the other elements we have? Calcium and oxygen. So it is only the oxidation number of carbon we are asked to find. Now, calcium is a metal, and then this is the principle for getting the oxidation number of metals. Any metal in group 1 metal, the oxidation number is going to be +1. Any metal in group 2, the oxidation number is going to be +2. Any metal in group 3, the oxidation number is going to be +3. As far as those metals are the ones starting that chemical compound, you can see calcium is the first element in this compound. All right. So calcium belongs to group 2 of the periodic table. So definitely the oxidation number of calcium is going to be +2. Then the oxidation number of oxygen, you must know that. I just gave that in the rule. It says the oxidation number of oxygen in most compounds is minus what? -2, except in peroxide where it is -1. Then this one is not a peroxide. Peroxides, they are higher oxides, all right? So calcium is going to be what? +2, because calcium is in group 2. So we are now going to have 2, all right? So, and what is the rule for calculating oxidation number when we have a compound? It says the sum of the oxidation number of the constituent element or the component element is equal to 0, because a compound carries no charge. The charge on a compound is 0. If you look at the top of this compound, there's no charge, there's no plus, and there's no minus. So definitely the charge on top is 0. So the oxidation number of calcium is 2. Then plus, we have to add to the oxidation number of carbon, which we are looking for. So I'm going to write C. So C represents the oxidation number of carbon. Then plus the oxidation number of oxygen is -2. Then that -2 we have to multiply by the number of atoms of oxygen present here, which is 3 atoms of oxygen. All right, that's times 3. Then everything will have to be equated to 0. All right, so that is the rule. So we have 2. We have to solve this mathematically. Plus C, then -2 times 3 will give us -6. All right, everything equals 0. So we have to collect like times, simplify. We have 2 minus 6 to give -4. So this is going to be -4 plus carbon equals 0. Then make carbon the subject of formula. Carbon will be equal to 0. And carry 4 here, we have +4, and then carbon is going to be equal to 4. So meaning the oxidation state of carbon in this compound is +4. Then you can be asked to name this compound to tell us the hierarchical nomenclature. That's the International Union of Pure and Applied chemistry system of naming a compound. Okay, so the name of this compound is going to be calcium. Then how many atoms of oxygen? We have 3 of them. So this calcium trioxo, meaning 3 atoms of oxygen. Then carbonate 4. So the carbonate 4, that 4 after the carbonate signifies the oxidation number of calcium. All right, we move to number 2. So number 2 says NO3 minus, and we are to find the oxidation number of nitrogen, which is the first element here. Now we have just 2 elements in this radical. Now this one is a radical. It's a bit different from the first question here. So this is a radical, and this radical is carrying a charge of -1. So please mind you, it is not oxygen that is carrying -1, but the whole of nitrogen and oxygen. So the whole of NO3 is carrying a charge of -1. So this -1 belongs to the whole of nitrogen and oxygen. All right. So how do we get the oxidation number of nitrogen? So we represent the oxidation number of nitrogen with N. Now we add it to the oxidation number of oxygen, which is -2. But that -2 has to be multiplied by the number of atoms of oxygen present in this compound. So that's going to be -2 times 3. And then everything equals the charge on this radical according to my rule, which is equal to -1. All right. So this is going to be nitrogen. -2 times 3 we give -6. Then equals -1. All right. Nitrogen, correct like times, equals -1. When 6 comes out, we have +6. Then N equals -1 plus 6. We give +5. So N equals 5. So the oxidation number of nitrogen in this radical is +5. So this radical or this ion can be named trioxonitrate 5 ion. So you have to put ion at the end of the naming. All right. So we move on. Number 3. Number 3 says Cr2O72 minus. Then we have to find the oxygen state of Cr, which is chromium. All right. Now this one is also a radical, and the radical is carrying a charge of -2. So the whole of chromium and oxygen is carrying a charge of -2. All right. So how do we get the oxygen state of chromium here? Now this time around we have how many atoms of chromium? 2. You know, in the ones we have done previously, you will discover that the one whose oxidation number we are asked to find is just 1 atom of that particular element. But this time around we have how many atoms of chromium? That's what? 2. So we have to multiply the oxidation number of chromium, which we are looking for, by the number of atoms. So that's 2 times chromium. So Cr, which is chromium, is the oxidation number that we are looking for. Then plus oxidation state of oxygen is -2. So that's -2. Then times, what's this? 7. So that's 7 atoms of oxygen. Then everything will have to be equated to -2. That's the charge on the ion. So 2 times Cr, just like you are saying 2 times X, that's going to be 2Cr. All right. Then plus -2 times 7, that's a -14. Then equals -2. All right. So 2Cr plus times minus is -14 equals -2. Then you collect like times. So we have 2Cr equals -2. When -14 comes, it turns to +14. So 2Cr equals -2 plus 14 will give us 12. Then you divide both sides by 2. So Cr is 12 divided by 2, and Cr is 6. So the oxidation state of chromium in this compound is +6. All right. What if you have to name this compound? This is going to be heptaoxodichromate 6 ion. Dichromate in the sense that chromium is having 2 atoms there. So that's why we have dichromate, because in chemistry, anything di is 2. All right. So we proceed to the next question. Number 4. All right. Question number 4 says we have to find the oxidation state of manganese in this radical MnO4 minus. All right. So Mn again represent the oxidation state of manganese. Then plus the oxidation state of oxygen again is what? -2. You can see that is a constant. Oxygen is always -2 except in peroxides. Then times 4. All right, then equals minus 1. So then we have mn plus minus 2 times 4 gives minus 8 equals minus 1. We have mn plus times minus gives minus 8 equals minus 1. Then make mn this such a formula collecting like times. We have minus 1 plus 8, and then mn equals 7. So the oxidation state of manganese in this radical is plus 7. And if I'm to name this radical, this is going to be tetraoxo manganate 7, meaning the oxidation state of manganese is 7. Then the last but not the least, we have NaH. NaH. So this is anhydride, all right? So we have NaH, and we are to find the oxidation state of hydrogen in this compound. Then please don't forget, although we know that the oxidation state of hydrogen is supposed to be minus 1, but I just want to assume that we don't know the oxidation state of hydrogen. But definitely you must know that of sodium. Sodium is in group 1, which is plus 1. All right, sodium is plus 1. So we are going to have 1, then plus H, then equals, now this is a compound, there's no charge on top. So you equate everything to what? To 0. So we now have H to be equal to, collect like times, 0 minus 1, and then H gives what? Minus 1. So we can see that the oxidation state of hydrogen in hydride is minus 1. So these are the rules. So those rules I gave to you, those rules, rule number 1 to 6, make sure you go through them, commit them to memory, and then apply them to any problem that comes your way. So thanks for watching. Please like, comment, subscribe, and share. God bless.